All right, folks. Thanks for coming. This is part 3 of our 3-part series on linear equations in two variables. This has been the application, all right? Application of linear equations in two variables to real-world problems, okay? So this is part 3. I think I'm gonna leave it here. After this, I'll leave it here. Then I'll go to something else. I think I'm gonna go to exponents and polynomials. All right. So we'll do this, and then we'll stop here, and we'll go do something else. I may still come back, like I told you many times. I may still come back. I find a bunch of problems and I solve them, and then I come back and post them under this topic. Okay. So I just want to touch different areas of applications. That way anybody that needs help can use them to help themselves. Before I continue, please subscribe to my channel, like and share this video. If you have any comments or questions, leave them under this video. So what we're going to do today, we're going to solve a bunch of problems, man. Yeah, I think I don't know how many problems I have, but I do have a bunch of them. So let's kick it out. All right, here is a problem number 1. It says the cost of business cards. I think the title is cost of business card. Don't worry about that. I don't know what they wrote it like. The cost of business card, and then it says speedy printing. The Speedy Printing is the name of the business. Okay, I don't like the way they wrote the problem. Speedy Printing charges $23 for 200 deluxe business cards and $35 for 500 deluxe business cards. Given that the cost is a linear function of the number of cards printed, find a formula for that function and find the cost of several hundred business cards. Listen, like I said, a bunch of words, man. A bunch of words. Basically, what they're saying is a company called Speedy Printing, right? The company charges $23, for printing 200 deluxe, what they call deluxe business cards. Okay, this deluxe is probably the businesses try to give their products name, and then the next level of business card is called 500 deluxe. Okay, the previous one is called 200 deluxe. This one 500 deluxe. 500 deluxe consists of 500 business cards, and they charge $35. Okay, so then the problem says that given that the cost is a linear function of the number of cards, in other words, the cost is a function of the number of cards printed, right? Find a formula for that function and find the cost of several hundred business cards. Okay, so what they did is they give you some numbers, and then they say, use the numbers, you form a linear equations. And so what we're gonna do, basically here is what is going on in the problem. Notice that they said first of all, cost, you see, is a function of number of cards. Okay, cost versus number of cards. Okay, so it says for $23, you get 200 cards. Okay, $35 you get 500 cards. Okay, you see that, right? So basically, if we look at it, the cost is a function of number of cards. We're gonna treat that later. What it means, something is a function. We've been talking about Cartesian coordinates. We say this is X and this is Y, okay? In this Cartesian system, f of x is represented as y. So so the value of y depends on the value of x. X axis is the number of cars, okay? And y axis is the cost. I think we did that before. Remember, we did that before. You know, where we have variable costs, fixed costs, and the other stuff. So basically, what they're saying is, you know, you always think in terms of ordered pair. What they're saying here is 200 cars is paired with $23, okay, and then 500 cars is paired with $35. That's all they're saying there, man. That's the ordered pair they have there, okay. You gotta try to understand that thing. Which one is dependent variable? Which one is independent variable? Because they say cost is a function of cars. Okay? Cost is a function of cars. So the number of cars, the cost depends on the number of cars you printed. Yeah, generally and basically, when you say that cost is a function, okay? It's a function of number of cars, okay? Make sure you understand that. That means that cost is the dependent variable, okay? Dependent. It means that the cost is the dependent, okay? Dependent variable. I'll explain that. We talked about that before. And then number of cars is the independent, okay? The independent, sometimes it's confusing. So basically it's like this, y is I think I said that before, y is equals to function of x, where this is y and this is x, you know. So you always wanna find what is on the x-axis, what is on the y-axis, okay? Because y-axis is always the dependent variable. It depends on what happened to x, okay? Because x variable is always the first one written here. So always remember that. The second written is the second written here is the y variable. So the y variable depends on the first one. The second one depends on the first one, and the first one is always x, okay? Always remember that, man. If you remember that, you shouldn't have any problem. Okay, so now that we'll have two ordered pairs, right? We can use that to find the slope. Once we find the slope, then we can write the equation as they want. We can write the formula for that function, okay? Alright, so let's do it. Remember, we've been doing this, we did this many times, okay? Now, you remember what I said, we can use it as initial, we can use this one as final, okay? And then we'll say slope. Slope, m is equals to rise over run, okay? The same thing as changing y, okay? Changing y over changing x, okay? And then we'll say it's right there. We'll start with the final. Is changing y is 35 minus 23, and then changing x is 500 minus 200, okay? What is that? Alright, and then we'll get in the denominator 300, okay? So, I mean, we can put that in a fraction, alright? And that would become 0.0 0.04. That's the slope, okay? So we get that. Once we get the slope, we can use any one of the other pair to form the, to form the equation. You remember, we have to use the, what they call the point slope, because we got 2 points, okay? So we use the first one. The first one is right there, and we use the slope, and then remember the point slope, y minus y1. See, that's why that equation is very useful. Mx minus x1. Usually this equation and this equation, this one here, mx plus b, they usually go together, because you see, if you just given the points, if you're given the points, you use that first, and then once you use that, you convert that to that one over there. So they always go together. So it's good to remember both. Okay, so we have that. Then what do? We use this one. Okay, we say y minus 23, right? Is equals to slope 0.04. Okay, 0.04 x minus 200. So you gotta know which one you're using. You don't wanna mix it all up. So we're using that. So which means we gotta use 23 and 200. Okay. All right. So we do that. What do we get? We simplify that. We get y minus 23 is equals to 0.04x. Okay, so 0.04, multiply 200. What do you get? You get 8. So that will be minus 8. Okay, and then we'll try to simplify. We'll move to minus 23 to the other side. We'll get y equal, it becomes plus when it goes the other side. 0.04x minus 8 plus 23. Okay, see that, right? So we'll simplify 0.04x. It will be plus now, because 23 is larger than minus 8. Okay, so that would be 15. All right. So basically, this is our. That's what is going on there. Our equation is y equals to 0.04x plus 15. That's our equation, okay? That's what they want. He said, okay, find the formula, or the formula of that function, and find the cost of 700. So, yeah, I don't like the way they phrase the problem. It's they kind of making it confusing. So basically, once we find this, what they're saying, then find the cost of 700 business cards. So that means they give you x equals to 700, okay? And they want you to find y. Always understand that, find y. Y is the cost. Then we'll say, we use that. We'll say y equals to 0.04x plus 15, okay? And then y would be 0.04 times 700 plus 15. That's all. See? So once you understand the problem, the rest are easy, So you gotta try to understand the problem first. Alright? So it becomes, if you multiply that out, you get 28 plus 15. It becomes what? It becomes 43. Yeah, it becomes 43. Right? So the cost is $43, man. So that's why it costs. So the cost is $43. That's all. That's all they want there, man. It looks. The problem looks. See the way they condensed it. It's condensed stuff, and they use words. They use words to hide a bunch of stuff. Because if you really carefully, given that the cost is a linear function of number of cards printed, so you gotta try to unpack that, see what they're saying there. Once you do that, the rest of the stuff are easy, man. All right, here is example number 2. The title is volume discount, and it said Mona Kalini gives a walking tour of Honolulu to one person for $49. She gives a walking tour one person for $49, right? To increase her business, she advertised at the National Orthodontist Convention that she will lower the price by $1 per person for each additional person. She will lower it $1 per person for each additional. In other words, she will charge $48 if there are 2 people, right? I think that's what that's saying. If there are 2 or more people, write the cost per person C as a function of the number of people N on the tour. Okay, how much does she make for a tour with 40 people? Now, you see what this problem is doing? They say cost. Write the cost per person C. I want to change that to Y. I'll tell you why. And then as a function of the number of people N, I change that to X. I'm not gonna use C, but you get the message. The cost is a function of the number of people she takes to the tour. Okay, this is the same thing we saw before. Like I always tell you, if you go to the Cartesian coordinate, this is Y, this is X. Y is written like this. This is the function there, and it's a function of X. That means Y depends on X. X is independent variable. Y is the dependent variable. Y depends on X. So you write, when you form the ordered pair, you put X first, and then you put Y, because Y depends on X. You see, so Y depends on X. All right, so let's go. So what are we giving? Okay, they even said it here, but I don't think we need that one. The first ordered pair is 1.49, and then she reduced the price by $1, which means if you have 2 people or more, she will charge 48. That's all that is saying there. That's all we need. We need to solve the problem. Okay, write the cost per as a function of the number of people. Okay, so they want us to produce the equation. That's what all that's saying. That's all that is saying. So we'll get the equation. How do you get the equation? Well, you gotta get the slope. First, you get the slope. Second, you write, you get the slope. And then second, you use the slope. Using slope, okay? Using slope, find this equation. What do you call that? Slope intercept form. Okay, plus Y. I'm sorry. That's Y intercept plus B. Okay, this is Y intercept, this is slope, this is X, okay? So basically that's what we're gonna do. Okay? So let's solve the problem. We'll find the slope first. So slope M is equals to, let's use that as initial. We use that as final like I normally do. Slope is change in Y over change in X, okay? Okay, so you know what is Y, you know what is X. This is X, this is Y. X, Y, okay? So change in Y is 48 minus, hang on a minute, it will do something wrong. 49, it really doesn't matter. We'll still, even if the the second one is smaller, it doesn't matter. It's 48 minus 49. Everything will work out fine. And then 2 minus 1, okay? So we do that, what do we get? We simplify that, we get minus 1. You see that? Over 1, which is minus 1. That's the slope. So slope is minus 1. So the equation will, when we draw the graph, it will slope down like that. That's all. That's all that is saying, you know. So don't worry about that. We'll take care of it. We'll find out what is going on. Okay. Okay, so, and then we use, what is that point slope from y minus y1 is equals to mx minus x1. We use that because we gotta use one of the points. Okay? So it doesn't matter which one we use. It really doesn't matter. I can use the first one or the second one. Let's go ahead and use the first one as we normally do. We'll have y minus 49 equals to the slope times the slope right here. Minus 1 times x minus x1. x1 is y. It's 1. Airplane is coming. Let me pause it. Alright. Okay, the jet has passed. I can stay here, the noise. So you simplify now, right? Then it's y minus 49 is equals to, you multiply out minus x plus 1. When you multiply minus 1 times minus 1, you get plus 1. Alright, say y, you move the other thing, you move 49 to the other side, it becomes positive. Minus x plus 49, I'm sorry. Basically 49 plus 1, right? You see that, right? Y equals to minus x plus 50. You see it, right? Alright. So basically that's it. That's it right there. That's our slope intercept form, you remember? So it means, well, of course we know that the slope is negative 1. Okay, so what are they want us to do? We found the equation. How much does she make for a tour with 40 people? Don't forget, people represent, you know, so 49 and then one person. Okay, this is person right here, and this is person right here, because she reduced it to 48. Okay, and this is the money here. That's the initial. Okay, fine. So it's what they say. Find the how much does she make for a tour with 40 people? So that means, so it will be x equals to 40. So we say y, we use this. Y equals to minus x plus 50. We'll put the value of x. We get y equals to minus 40 plus 50. See that, right? So it will be y equals to, that's minus 40 plus 50. You see it, right? So you subtract that, what do you get? You get 10. So she will make $10, man. Okay, that's the cost right there. How much does she make for a tour with 40 people? Okay, y is the cost, right? Y is the cost. Okay. Y is what the cost per person as a function of, okay. Yeah, y is the cost. So if she take 40 people, the cost will be that. That means, okay, so if you take 40 people, so then you see, once you get that 10 times 4, that will means, what is that? It's 400. That's what she would take in. That's what she would charge. It's kind of confusing, man. It's a little bit confusing. That's the cost, and that's what she would take in. She would take in 400, okay? That's what she will make that the $400. You know, it's a little bit confusing, man. What is y? See, you gotta see, the cost per person is that. So that's the cost right there. Sorry. This is the cost right there. That's the cost. And then she would take in that, okay? But anyway, sorry about that. It's a little bit confusing the way they word the problem. So we're done with that. We're going to move on to something else. Okay, here is our next problem. It's ticket pricing. At $10 per ticket, Willie Williams and the Wranglers will fill all 800 seats in the assembly center. The manager knows that for every $1 increase in the price, 500 tickets will go unsold. Write the number of tickets sold N, okay, as a function of the ticket price. Alright, how much money will be taken in if the tickets are 20 each? Okay, and they give you a bunch of that. That's $10, and then you know that is sold, and then ticket is $11. Then that will be sold. Okay, ticket $12. That will be sold. You know, that's the hint they give you. So don't forget always go to Cartesian Y and X. Okay. So this problem is saying that. By the way, I'm gonna change the number of tickets sold. This problem is as a function of the ticket price. Write the number of tickets as a function of the ticket price, okay? So basically, the price, the ticket price, the price is right here. Price is X, and the number sold is Y, okay? Number sold, number of tickets sold, okay? You see, that's what that's how they put it, because this is price, this is price, and this is price, and you know the big numbers are the number of tickets sold, so they just put that as Y, okay? So basically, write the number of tickets. You know what? I'm gonna switch this. I'm gonna switch instead of N. I'm gonna use Y here. Instead of P for price, I'm gonna use X. Okay. So that's how I wanna do it. All right. So then we'll say we'll have 2 points, 2 ordered pairs, 8,000. And then 7,500, okay, tickets. Because he said $10, at $10 they will say 800. The manager knows that for everyone, if they increase it $1, which is $11, right? 500 tickets will go on, so subtract 500 from 800. I mean, from 8,000, you get 7,500. So the first step will find the slope. Slope M is equals to, we use the initial final, okay? Slope is equals to change in Y over change in X, okay? That would be the same thing as, 7,500 minus 8,000 over 11 minus 10, okay? So if you do that, what do you get? You see what is going on, right? You know, I mean, some of the stuff are given away. The difference between those two on the numerator is negative 500, because that's what they subtracted. And then difference between that is 1. So basically it's negative slope 500, okay? The slope is 500. That's all that is saying, man. Okay, it's negative, you see? It's a negative slope. But anyway, so once you get that, you see what that thing is very, very useful. That's why that our thing is very useful. Hang on a minute, let me check something. Alright, so you see why that point slope formula is very, very important, you know, because it goes hand in hand with slope intercept form. You start with from point slope, you end up with slope intercept form. So point slope is y minus y1 is equals to mx minus x1. Just remember this formula, and the other one you should be okay. And then we'll have slope, and we use 1 point. We can use the first one, it doesn't matter. We say y minus 800, 8,000, okay, is equals to minus 500, that's the slope, x minus, what is that, 10. Okay, you just have to be consistent. If you choose one point, you stay with it. Okay, so we simplify that. What do we get? We get y minus 8,000 is equals to minus 500x. Okay, times, when you multiply negative and negative, it becomes positive, times 5, it becomes 5,000. Okay, you see that, right? So y will move 8,000 the other side, it becomes minus 5, negative 500x plus 5,000 plus 8,000. Okay, that's this. What is that? It's 13,000. Okay, you see it, right? Because 8 plus 5 is 13. Okay, so why is that? All right, so basically that we found it. That's what we're looking for there. That's the equation that models the problem. See, once you get the equation, it's actually, this is slope intercept one with slope is negative 500. Okay, y-intercept is that. So with that you can draw the graph, but we don't need to draw the graph. Okay, so that's what we are given there. And then what do they want? They say find how much money will be taken if the tickets are $20. Don't forget the tickets are the price, right? And the x-axis. So if the ticket, if x is equals to 20, that's what is asking you. Then y is the number of tickets sold, but they want how much money will be taken in. So we'll find the number of tickets sold, because y is the number of tickets. So we use the price and find the number of tickets minus 500, and we put in this thing here. 520 times 20 plus 13,000. Okay, so we'll simplify that. What do we get? So make sure you understand what is happening, man. All right, so what that comes to is minus 10,000. Okay, plus 13,000. Okay, 10,000. You take 13,000 and subtract 10,000. What do you get? You get y is equals to basically 3,000. Okay, that's the number of tickets she will sell. If the price is $20, she will sell 3,000 tickets. But what they want, how much money will be taken in if the tickets was, so how much money taken in, you multiply the number of tickets sold and the price, then you get 3,000 times 20. That's all they want you to do, man. The money taken in will be that. It will be 60,000. Okay, 60,000 will be taken in. That's the money. Okay, that's the money they're gonna take in. 60,000. All right, I think we're done with that problem, man. Okay, here is the next problem. I read that it's about computers and printers. It says an office manager will spend a total of 60,000 on computers at 2,000 each, and printers at $1,500 each. Write the number of computers purchased as a function of the number of printers purchased. Find and interpret the slope. I like this problem because it brings a lot of stuff we're gonna deal with later on. Notice how they condense. They give you a lot of stuff in that statement right here. See this statement right here? They give you a lot of information there. Okay, notice that we've been saying this. Notice that in the Cartesian coordinate system, right? The Cartesian coordinate, this is x and this is y. And they say y is a function of x. That's how that is written. Y is written as a function of x. This is f is function of x. You see what it says there, right? The number of computer purchased as a function of the number of printers. So basically this is computer here, and that in there, X is the printers, okay, number of printers purchased. So number of printers purchased is written as a function of Y. Number of computers purchased is written as a function of printers. So computers, okay, is a function of printers. That's all that is saying, man. Right there. Computers is a function of printers, like that. But how do you translate that? You gotta be able to translate that into that. Okay? So Y is equals to a function of X. Printers is X. Y is computers. You see that, right? So knowing that, so what we need to do, let me change the ink. What we need to do is I'm gonna proceed this way. Say write the number. Okay, what I would do is we'll have to find the points. We'll find 2 points. We'll get the slope, and then we'll write the equation like we did in the previous problem. Okay. Actually, see the hint they give you. Look at the hint. It says start with standard form. Okay. So basically, they spend a total of 60,000. Okay. And they get per computer is 2,000. So let me see. Well, let's say computers. Don't worry about that. And then we'll translate. That's times each computer is 2,000. So that's times C for computers. And then printers cost 1,500. That's per printer. Okay. So how do we translate this into? I think that's what this is the standard form. That's what they're saying. This is the standard form, and you're dealing with 2 variables. Don't forget that you're dealing with 2 variables. Standard form of 2 variables is like that. Okay. Another way you can see it is like 2,000 C. C is a variable plus 1,500 P. P is a variable. Is equals to 60,000. So this is perfectly in standard form. But you need to I like to use Y and X. Okay, so how do you translate this? X are printers, Y, according to what the way I like to do it, Y means computers. So let's do it this way. We say 2,000 Y plus 1,500 X is equals to 60. I think I did it right. Let's solve it and see. So I mean, we could have solved using the variables, but I like it this way because he says computers is a function of printers, right? And when Y is a function of X, then you write it like that. So X printers, Y is equals to C. You get that, right? So let's solve this. Remember, you can always convert the standard form to slope-intercept form. Remember the slope-intercept form is this form here. Let me see. Let me write it over here. It's Y is equals to slope times X plus B. B is the y-intercept. Okay. So we can put that in that form. All right, by manipulating the stuff. So we'll say 2,000 Y is equals to minus. We'll move this over to the other side. It's 1,500 X plus 60,000. Okay. All right, plus 60,000. All right. You see that, right? What we need to do, we need to get rid of 2,000 on the left hand side. Okay, then we'll say we divide everything with 2,000. We get Y is equals to minus 1500x over 2000. You see that? Okay. Plus 600. That's 60,000. Okay, that's 60,000 right there. I don't know where that dot came from. That's 60,000 right there. Divided by what? You divide that by 2,000. Because we want to get rid of 2,000 from y. Basically, we try to transform this into that, okay? So you divide things out. What do you get? You get y is equal. So actually, you cross these things out. 2 zeros out there, right there. 2 zeros, another 0. So you get minus 15. Let me say 15 over 20x. Don't forget x plus 60. Let me see, 60 over 2. Yeah. Okay, so you simplify. What do you get? 5 divided, you get minus 3 over 4, right? X plus 2 going to 60, we get 30. Okay, see, that's what we're looking for. That's it right there. It's in that form now. Okay, so since it's in that form, we say slope is equal to negative 3 over 4. You see it, right? That's all the information we need. This is y-intercept, but we don't worry about that. Okay, so what the problem says is find and interpret the slope. We found the slope. That's the slope right there. What does that say? It's a negative slope. Okay, it's a negative slope. So what that means is because you see this represents, don't forget this represents printers, okay? Printers, this represents computers. You remember? Go back, it's over here, you see? Y, computers, X, printers. So that means what we see there is, the way we interpret that is, if they buy 4, they have to buy 4 more printers. Right? When if they buy 4, they have to buy more printers when they buy, every time they buy 3 computers. That's all that means, man. There are many ways you can say that. So they buy 4 more printers if they buy 3 fewer computers. You can say it that way too. That's all that means. That's how you interpret that. Okay, 4. Sorry. Let me use a black pen. Basically, all that means is, let me see. 4 more printers for 3 more computers, okay? I mean, that's how I interpret it. You can say 4 more printers, then they have to purchase 3 fewer computers, something like that, man. You know, so, but anyway, so basically we're done with that problem. Let's move on. That's all they want. We'll move on to something else, okay? Okay, here is example number 5. It's about carpenters and helpers. All right. It says because a job was finished early, a contractor will distribute a total of 2,400 in bonuses to 9 carpenters and 3 helpers. All right. And then it says the carpenters will get the same amount and the helpers will get the same amount. Write the amount of a helper's bonus as a function of the amount of a carpenter's bonus. Find and interpret the slope. Again, it's almost the same thing as what we did before. It's almost the same thing as, write the amount of a helper's bonus as a function. Helper's bonus as a function of the carpenter's bonus. Remember what I said before? when you say y is equals to a function of x, okay, and you have you draw the stuff in the Cartesian coordinate, right? If you draw it in the Cartesian coordinate system, what does that mean? It means you have you like this x, y here, okay? You see that, right? So, and we'll say y is a function of s. But here it says, in our problem, it says helpers bonus as a function of carpenter's, the amount of helpers bonus is a function of the amount of carpenter's bonus. You see that, right? So basically, it's a function of something. So here is the helpers are here and the carpenters are here. Okay, the carpenters are here. Alright, so you need to get that squared out. Yeah, helpers are here. These are the carpenters. You get that, right? Okay. So basically, it's similar to what we saw before. What they're asking us to do is they distributed a total. This is the total distributed. What they're asking us to do is, because we don't have any points, no points given, we can't find the slope using points because we are not given any points. So I like this problem because it teaches you something. So what we're gonna do, we need to first form the standard, what they call the standard form of linear equations in two variables. So the total is right there, which is 2400. Okay, you distributing that to carpenters and helpers. Okay, all right, 9 carpenters and 3 helpers. Okay. So, what do? Then you say, since there are 9 carpenters, let me see, 9 carpenters and 3 helpers. That's all that is saying. They're going to share 2,400, okay? But you see, I like to do it in X and Y. Like I said, carpenters will be X and helpers will be Y, because it says helpers is a function of carpenters. So I would say 2400. Well, I don't have to go repeat that. Let me remove carpenters. Sorry. I remove C and the H and put the variables I like to work with. You can work with whatever you want. I like to work with X and Y. Okay. So let me clear that out. What is my doing right here? Carpenters will be X. Okay. What's wrong with my pen, man? My pen is not writing. Carpenters will be X. Okay. And then helpers will be Y. That's what we want to do. Helpers will be Y. That's what we have there. So what we're going to do, basically this is the standard form. Standard form of 2 equations. Well, 2 linear equations in 2 variables, okay? You see that, 2 linear equations in 2 variables. So that's all that means. So basically we can write it like this. We can write it as 3y plus 9x is equals to 2400. Okay, we'll try to isolate y, because now we want to put it in this form. Our objective now is to put it in this form. This is called slope-intercept form. That's our objective now. And then we'll say we say 3y is equals to minus 9x, okay, plus 2400. You see that, right? So we want to get y by itself like that. So we divide everything by 3. We say y is equals to minus 9 over 3x plus 2400 over 3. You see that, right? Alright. So we'll simplify. It will be y is equals to 3 can go into 9. It gets 3. It will go 3 times 3x plus 3 go into 24. What do you get? You get, I think you get 6, right? No, actually, you know, 3 divide 24, you get 8, and then you bring 0, 0. So that's what you get there. You see, we'll form the equation right there. You see, that's what we got. So we'll notice that the slope is minus 3. Okay. So how do we interpret that? That's what they want us to do, man. The slope is minus 3. The most important thing is, see, we went from here, the standard form, we translated that into the slope intercept form. That way we can get the slope. We were able to get the slope. So how do we interpret the slope? Is negative. And what is all this stuff? He distributed 2,400 to 9 carpenters and 3 helpers, okay? Alright, so that means there are 9 carpenters, let me see, 9 carpenters and 3 helpers. So that means if 3 carpenters, if each carpenter will be given, let me see, actually, see, write that slope. Do me a favor, like we did before. Write that as, let me clear this up, because it will help you to interpret it. Write that as equals to negative 3 over 1. It didn't change nothing. It is still something as negative 3. So this is x and this is y. And what did I say y is? Right here. Y is helpers and x is carpenters, right? See, that will help you interpret this, man. If you write it like that, because it was dealing with the rise over run, okay? Rise over run. So if you do that, that means if the carpenters get $1, then the helpers will get, okay, the helpers will receive $3 less, because that's actually I think I got it, because you gotta put the negative sign like that. You could put it any way you want, but that's the best way to put it right there. So if the carpenters get $1, the helpers get $3 less. That's all that means, right? And these are bonus. The carpenters get $1, then the helpers will get less. So that's all that means, man. That's all that means. You can't read it more than that. So but anyway, we'll finish with that problem. We'll leave it there, man. We'll go to the next one. Okay, here is our next example number 6. It's about life expectancy in US, okay, in the United States. I'm going to read it. The points on the graph indicate years of life expected at birth Y in the United States for selected years X. It says here X is equals to 0 represent 1930, X equals to 10 represent 1940, and so on. You see, the graph of a linear equation that models the data is also showing the graph. They show the graph is right there. Okay, then it said, number 1, use the ordered pair showing on the graph to write an equation of the line that models the data. give the final equation in slope-intercept form. So make sure, so use the point to write the equation that models the data. So we are here doing, we've been doing data modeling, okay? You're given a bunch of points and then you're gonna model it. Anyway, so let's go. You see the points given is right there and that point right there. So number I, you see they give those 2 points. Let me see. The 2 points given, the 2 ordered per 059.7. Okay, and then it's given 87.8.7. You see that? So those are the 2 points given. Yeah, those are the 2 points given. They want us to use that to model the data. Okay, so okay, so they want us to use that. So what we'll have to do first, to get the equation, first you get the slope. Okay, remember that's what we'll be doing. Slope m is equals to, you said this is initial and this is final, okay? And the slope is change in y over change in x, okay? And then this is y here, x here, okay? So the change you are looking for 78.7, all right, minus 59. What is that? That's 59, right? Let me see. Yeah, 59.7. Let me clean that up a little bit. I didn't write it well. That's 59.7. This is y, okay? 59.7 over 80 minus 0. What do you get there? You do that, you will get, you get 19 over 80. Alright, so we'll have to work with fractions. So you divide that out, you get this, you get 0.2. It's given in 1 decimal place. I don't know if we want to go to the 2 decimal places. So we can go to 2. It's a 2.4, 0.24. I'm sorry, 0.24. All right. So that's the slope. We got that slope. M equals to 0.24. Okay, so that's what we got. And then what do you do? So we use the slope. We're looking for the slope intercept form equation. We use the slope at 1 point. We can use the first point, and then we use our famous one of our famous equations, point slope form. Slope x minus x1. Okay, we use that. We get y minus. We're using the first one. What is that? 59.7. Okay, it's equals to slope is 0.24. Okay, x minus, what is that? X is 0 there. So we keep going. Y minus 59.7 is equals to 0.24x. There's nothing there, 0. Okay. So we get rid of the stuff on the left. We get 0.24x plus 59.7. You see that's the equation we're looking for. Okay, that's what they want us to find. That's slope intercept form. You can compare to this one. Y is equals to mx plus b. So it's in this form. Okay, that's the form we're looking for. It's in that form. Okay, so So what do they want? Use the equation from I to do the following. Find years of life at bat in 2000. What is the value of x for 2000? Okay. So what is 2000? See, these are years here. And they said these are age in years. Okay, they say x1 represent 1930. X equals to 10. X equals to 0 represent 1930. X equals to 10 represent 1940. Okay, and so on. So this is it's an interval of 10. 1930, 1940. You see that? It goes by interval of 10. So over here is 1950. I mean, that's how I understand it. 0, 1930, 20. 20 is, hang on a minute. Oh, hang on. X equals to, just give me a minute. I want to make sure I understand this, man. X equals to 0, represent 1930. And then it says x equals to 10, represent, just give me a minute. We gotta get this right. X equals to 0, represent 1930. X equals to 10, represent 1940, and so on. Okay. Okay. So if we keep it, it's increasing every 10. From here to here is 10 years, right? So then we're gonna say x equals to 20 represent we're at 10, 1950, right? 40, then 30. Okay. So it's increasing by 10. X equals to 30 represent 19 what is that? 1960. That's what they want, man. You gotta keep going until you get to 2000. That's all they're saying there, man. X equals to 40 represent 1970. See that? So over here, actually over here, let me say over here, 0 is 1930. 20 is 1950, not 1940. I made a mistake there. So forget about this one. Forget about that. Let's find it. X equals to 50 represent 1980. X equals to 60. Oh Lord, it represent 1990. X equals to 70 represent 2000. Okay, you see that, right? So, oh Lord. So what they want us to do, find the years of life expectancy birth in 2000. What is the value of x in 2000? Round to the nearest tenth. So what they want us to do is, that's how I understand it. If x is equals to 70, okay, and then we'll find the value of y. Y is equals to 0.24 times 70 plus 5, 9.7. What is that? I think that's what they want us to do. I mean, I don't know how else to read that, man. Okay, 0.24 times 70. Okay, you get 16.8 plus 5, 9.7. Okay, so that's how I. Okay, so that's 76.5. What is that? That's years, right? Y represent age. That's the age. That's the number of years that person is. 76.5. That's the best I can do, because X is 70. I think we did that right. You see, if you go according to what they give us here, make sure you pay attention here. That thing started, where is that thing in the problem? It started here, right there. Says and so on. So you gotta keep going until you get to 2000. Okay, so we did that. What is the stuff they want? They said B. How does the answer in part A compare to the actual value of this? 76.8. Yeah, it's close. You said that's B. Oh, what am I doing? Find the years in. Okay, that's this is A here, and this is B here. Okay, so yeah, they want us to compare what we got. Compare. That's all that is saying. Compare what we got to the actual value of what they say 76.8. 76.8, you see, and we got that. So it's close, and they are close, man. They are close. That's all I can say. They are close. They are close, but this is, you see, that's a lot of they are close, man. That's all I can say. So we'll leave it there. We're done with that. We'll move on, man. All right, here is our example. Example number 7. We did this problem before, but we did it in part 2. But we did the tablets. I forgot to do the computer, the desktop PC. So we're gonna do the desktop PC here. It says the graph shows global shipments of desktop PCs and tablets in millions of units from 2010 through 2016. Use the graph to work each problem. Now you see, it said now locate the line on the graph that represent PCs. Before we did locate the lines on the graph that represent tablets. Now we're doing PC, okay? Now we're doing PC instead of tablets. Okay? So the line that locate the line that on the graph that represent PC, that's the red line, okay? Write two other pairs where X is the year and Y is the shipment in millions of units to represent the data for the years 2010 and 2016. See, 2010 is here, 2016 is actually, sorry, I'm gone to a different right here. 2010 is here for PC, 2016 is here, and they say write the other pair. So notice that this is 2010 here, this is 2016 here. So the other pair they're looking for number A is because the x-axis is represent years, is 2010. I'm sorry, 2010 and 157, okay, and then 2016 and 103. You see that 103 for PC, 157 for PC. Okay, so that's what they want. You say use the other pair from part A to find the slope of the line. Okay, you remember slope? Slope is m equals to change in y over change in x. Okay, so we say this is final, this is initial. What is that? We have the y values are 103 minus 157. Okay, I don't know why. Yeah, okay, it's a negative slope because you see, if you look from here, it slopes down. The PC, the red line slopes down. See, so it has to be negative. Okay, 103 minus 157, it will give you a negative number. What is the other one? 2016 minus 2010. Okay, what do you get? You get negative 54. Okay, over. What am I doing? This is hang on a minute, I made a mistake. That's why you gotta write clearly. This is 2010, okay? I don't know why I'm saying subtract. You can't divide by 0 right here, okay? 2016 minus 2010, that's a 6. Okay, so So our slope is -9, okay? Okay, so that's the slope. M is -9, okay? See, see the graph, the red graph is slanting downwards from left to right, okay? And then C, okay, actually this is B. And then C, he say you interpret the meaning of the slope in the context of this problem. Okay, so to do interpretation, as you go, you learn more. Notice that this slope can be written as -9 over -1. Okay, so let's make sure we understand that. Okay, it can be written as -9 over -1. What does that mean? Okay, notice that X is years, okay? This means years, and this means, what is that? This means millions in number of computers sold, number of PCs sold in millions, okay? In millions. All right. Okay, so the way we interpret that is, we can say the shipment. They shipped the desktop PC. They shipped. What is between? Between. Let me see. They shipped. It decreased by. Let me see. Yeah, that's right there. It decreased by 54 millions. 54 million units in 6 years, because from here, actually, we're supposed to interpret right there, because from here to here is 6 years. You see that? 6 years. Okay, so it decreased 54 million units in 6 years. That's all. That's all it's saying. So if you divide that out, it means it decreased every year. It decreased 9 million units per year. You see? So that's how you interpret that. Okay, I think we're done with that. You see? Well, let me write it down. Shipments. Okay. Shipments decreased the 54 millions in 6 years, or you can say the same thing as saying that, use this one here, shipments decrease 9 millions, okay, every year for 6 years. Well, every year for 6 years, okay? Sorry, every year for 6 years. That's all you can say there, okay? So that's what that means there. Okay, so we are done with this problem. Okay, here is our next problem. It's about temperatures, right? It's about temperatures. It says, if we think of other pairs of the form CF, then the two most common methods of measuring temperature, Celsius and Fahrenheit, can be related as follows. C is equals to 0, F is equals to 32. Right? I'm sorry, when C equals to 0, then F is equals to 32. When C equals to 100, F is equals to 212. Okay, notice what is going on there. This is X value, this is Y value, okay? But we're gonna let's work in terms of Celsius and the abbreviation of Celsius and Fahrenheit, okay? So we're gonna use those C and F. Alright? And then it says work the following 8 problems in order. You do it in order. Write 2 other pairs relating these 2 temperature scales. So these are temperature scales. Look on the right hand side, you see the scale. Look, the big numbers represent Fahrenheit. The small number represents, see right there, Celsius and Fahrenheit. Okay, so what they want is, number one, find the ordered pair. You're gonna use these numbers and get the ordered pair, okay? Alright. So the ordered pair would be, basically it would be in form of C and F, okay? Alright, so the ordered pair we'll have there is C is first. It will be 0 and 32. And then another order pair is 100 and 212, okay? You see that, right? And then this is number one. Number two, find the slope of the line through the 2 points, okay? So the slope, you have 2 points, so you can find the slope. The slope is, remember slope? Slope is m equals to changing basically now, before we're talking about changing y over changing x. So to say it appropriately, we can say slope is change in f over change. I mean, how else do you want me to say changing in Celsius, like that? So we'll solve that, we'll get, what is it? We'll say this is initial, this is final. So we'll say change in Fahrenheit is 212 minus 32. Change in Celsius is, let me see, 100 minus 0. So if you work that out, you're gonna get, it's gonna be 180 over 100. This cross out, then it's gonna be 18 over 10. Divide this by 2, you get 5. Divide this by 2, you get 9. So it's 9 over 5. Okay, see that, right? Let's work with fraction that is not with decimals, okay? Alright, so we got the slope right there. With the slope, what they want us to do in number 3, use the point slope form to find an equation of the line. Use C and F as a variable rather than X and Y. See? So they want us to use C. Okay, so remember that our equation normally is normally, let me tell you, so normally in this form, because, let me see, what do you want? Find the slope of the line through 2 points. Use the slope form to find equation of the line. Oh, the point slope. Use the point slope, sorry. Okay, but they want you to use C and F rather than X and Y. Okay, remember normally when we do this, let me write it in red, then I will translate to what they want. We usually write it like this: y minus y1. This is a point slope. That's how we normally write point equals to the slope times x minus x1. You see that? So if we mimic that, we're gonna say is C minus not C, because C is in the numerator. Sorry about that. It will be F minus F1 is equals to slope. Okay, then C, alright, C minus C1. You see that, right? That's what they want. Okay, so we can use any point, any of the, well, let's use the first one to then find what they want us to find. So we'll put this one here, we use that one. We'll have F minus, what is F1 there? Is 32. Is equals to, slope is 9 over 5. Okay, that's what we'll find here. M is equals to 9 over 4. And then is C. We'll have C1. Where is C1? Let me make sure you see everything clearly. That's C1 right there. C1 is 0. So C minus 0. So we simplify that. That will give us F minus 32 is equals to 9 over 5c. And then the rest is 0. See that, right? Okay, so but we'll have to put it in there. He said find the equation of the line. Okay, we can't leave it in that form. Let's put it in slope, what I call slope intercept form. And then we move 32 the other side. We'll have f is equals to 9 over 5c plus 32. You see that? That's the slope intercept form right there. Basically, the slope is 9 over 5. You see that, right? And this is the, if we would draw the graph, this is the y-intercept. Or you can call it the f-intercept, since we're dealing, f is y. Okay? So you see it there, right? That's number, let's see, that's number 3. So we go to number 4. What is number 4? You say write an equation for f in terms of c. We just did that, man. We just did that. So it's f is equals to 9 over 5 c plus 32. We just did that. So that one is already done. So we'll copy that over. Okay. I think I was jumping the gun. Use the equation from 4 to write an equation for c in terms of f. Notice what is going on. This is f. F is written in terms of c because c is over here. But they want us to change it. That we see what that means. Number 4 means if you have a Celsius, have a figure in Celsius, you substitute it here, and then you find f. But now they want us to move c to the left and bring f inside. It's actually very easy. Okay, so let's do that. That's number 5. So we'll have this from number 4. We'll have f equals to 9 over 5c plus 32. You see that, right? Okay, so we want to rearrange stuff. So we'll say f minus 32. We'll move 32 to the left. Equals to 9 over 5c. You see that, right? So we can even, it's okay, we can stay like that. And then we'll multiply both sides by 5 to get rid of 5 in the numerator. And then we'll have, because you can picture that as 9c over 5. You see that, right? 9c over 5. We'll multiply both sides by 5. And then we'll have 5f minus 32 is equals to 5 times 9c over 5. You see that, right? So this will cross this out. I'm gonna run out of space, man. So I'll try my best. See, I write so big. So let's keep going. I just want to make sure you see what I'm doing. If you simplify this, what do you get? You get, because we don't want to work with fraction, we'll leave it like this. F minus 32 is equals to, simplify the right hand side, you get 9c. Okay, we can switch things around. We can say 9c is equals to, we're not changing anything, we're just exchanging places, okay? F minus 32. I want to put it in the form everybody recognize. So to get rid of 9 from the left side, you say c, you divide by 9. 5 over 9 f minus 32. You see, you recognize that even from, you see that? That's what we're looking for, man. So if you given the Fahrenheit, you substitute, you get the centigrade, okay? So we're kind of running out of space. Let me go. So we'll go to number, sorry about this, man. It's all messy. We'll go to number 6. What is number 6? Number 6 says, use the equation from 4 to find the Fahrenheit temperature when C is equals to 30. Okay. You see now, number 4, you see? When C is equals to 30, look at number 4. When C is equals to, they want you to find F. Then F will be, when C is equals to 30, C is equals to 30, okay? Then F, using equation here, F will be 9 over 5 times 30 plus 32. You see that? Okay, so you keep simplifying, keep going. What do you have? You have, what is 30 divided by, if you take that, you divide it by 5, you get 6. So basically it's over here, so that cross out is 6. 6 times 9 times 9, you see that, right? It will be 54 plus 32, and it will be, what is that? What is the temperature? It will be 86. You see how we got that, right? So that's what they want there, man. It's 86 or whatever, 86 degrees. So when you have that Fahrenheit is 86, when you have Celsius equals to 30 degrees. That's all that is saying you there, number 6. Okay? Because that's right there. See? Okay, so let's do number 7. What is number 7 say? Number 7 say use the equation from 5. Right? To find Celsius temperature when F is. Okay. Then we're doing the same thing. See, from 5, the equation we found is over here. He say use that when Fahrenheit F is 50. That's number 7 now. I'm reading here. Okay, so if F is equals to 50 degrees, what do we have? We're using this. We'll have C is equals to 5 over 9 F minus 32. So we'll put F equals to, because I don't have space, so I don't have the luxury of space, so I'm gonna go ahead and put it in there. It's 50 here, okay? So it's a 5 over 9. We're not with decimal. We'll try not to work with decimal. 5 over 9. Okay, then 50 minus 32. What is that? You see? So that's 18, you see? You see? So see why it's good to stay with the fraction rather than decimals. So you see, because this will cross that out, you get 5 times what? 2, which is 10. So it's 10 degrees. You see that, right? Okay. So if Fahrenheit is 50 degrees, Celsius will be 10 degrees. That's all that is saying. Okay. So so number 8. What are they wanting number 8? For what temperature is F equals to C? You see that? Use the thermometer above to check the answer. Okay. So what is that telling us is we can take this. We can take that. Let's take that one there. If we take that one, we'll say C is equals to 5 over 9 plus F minus 32, right? You see that, right? But they say F is equals to C. So they want to eliminate, let's eliminate one variable. Then we'll say C is equals to, C is equals to 5 over 9, okay? Because C is equals to F. So we'll replace F with C minus 32. You see that? Okay. I hope you see that, right? So we'll have one variable now. So we'll solve for C. Alright, so that will be that would be 9c is equals to 5c minus 32. You see that, right? See what I'm doing? Okay. So that would be 9c is equals to 5c minus 5. You do 5 times 32, right? And you get 160 minus 160. Okay. And notice what is going on, man. So we want to keep c positive. So we'll say 9c. We'll move this to the left. Minus 5c is equals to negative 160. You see that, right? So that here it becomes 4c equals to negative 160. You can have negative degrees, remember? Okay, so we say c is equals to what? Negative 160 divided by 4. What do you get there when you do that? You get 40, negative 40. You get negative 40 degrees. So that's what that is. That's what they're asking us to do. You see that, right? So if you don't see that, we can also use this equation here. We can use, because we use this equation here. We use that. If you think we're playing some trick, let's use the equation in number 4 and see what we got. If we use the equation, I'm doing more work now. If we use the equation in 4, let me see, I need to conserve space. We'll have, it says C is equals to F, right? Or F is equals to C. And then we want to use this is equals to 9 over 5 C plus 32. Okay? We got 40 minus 40 degrees. Now we substitute C with F. Okay, so we get 9 over 5 F, because C is equals to F plus 32. You see that, right? So we'll solve for F. Again, if you solve for F, all right, what do? You're gonna do, let me see. You're gonna do like this: F minus 9 over 5F is equals to 32. You see that, right? Okay. So you're gonna have to combine the left side. If you combine them, what do you get? You get, we use our usual trick. We'll say, because we want to have the same denominator, we'll say 5F over 5F is the same thing. It's the same thing as F, okay? And then we'll keep going. 9F over 5. You see that, right? It's equals to 32. Okay, so we'll combine the left side. We'll get 5. Let me see. It's 5F minus 9F, okay? It's equals to 32. And then what is that? What is that? We get, let me see. We'll get C is minus 4F over 5 equals to 32. Okay, you see that, right? So we'll multiply, yes, because it's 5F minus 9F over 5. So we'll multiply. If we multiply the other side, we want to get rid of 5 in the denominator. We'll multiply the other side. Okay, 32 times 5, okay, is 160. So we get minus 4F is equals to 160. And then F is what? F is equals to, it becomes minus 160. 160 divided by minus 4. What is that? It's minus 40 degrees. You see that? That's what we got before. Because it's assuming that both of them are equal. Because it has to be equal. That's the assumption. So it has to be equal to C, which is minus 40 degrees. That's what we got over here. You see that, right? So both of them are, if they're equal, then they're equal. That's what they're saying there. Okay, since the problem asks us to compare to the graph, let's see. You see, it asks us to compare to the, use the thermometer above to check the answer. Actually, see, right there, we're right. I did it using two equations, okay? Remember, I did it using that, and I also did it using that. And we got the 70 minus 40. Look over here. Look, the first scale is minus 40, and here the small scale is minus 40. So we did it right. Okay, so we'll solve the problem. I'm done with that problem. Let's move on. Okay, here is the next example, number 9. It says the points on the graph show the number Y of members of the professional social networking service LinkedIn in millions for selected years X, where X equals to 0 represent 2010, X equals to 1 represent 2011, and so on. The graph of a linear equation that models the data is also showing. That's the graph right there on the right hand side. Okay, so X equals to 0 represent 2010, X equals to 1 represent 2011, and they will keep going like that, repeating like that. Then you say A, because the points of the graph lie approximately in a linear pattern, a straight line can be used to model the data. Will this line have positive or negative slope? Okay, by now we should know. Look at it. It's a positive slope, man. You know, if you look at that, it's because you see, you always want to look from left to right, and you see the curve slants upwards. So if there is a car, let me see, if there's a car here with the tires like that going up the hill, you see, it will be going up. So it's positive slope. So that one is that one is easy. From left to right, you look at it, it's positive. The slope is positive. Okay, positive slope, okay? Because it's going up. It's not negative. Okay, so that one is easier. I numbered the way I want to solve it, A, B, C, D, as they gave us the problem, okay? So the first one is positive slope. What is that? Write two other pairs. Write two other pairs X, Y for the data for 2010 and 2016. Now, don't forget, man, it says 20, see how the level is, each year is represented by number. 2010 represented by 0. 2011 represented by 1. 2016 represented by 6. This is 2010, 2011, hang on a minute. 2010, 2011, 2012, 2013, 14, 15, 16. So it's represented by 6. Okay? So what do they want to say? You say find the 2010. Let me see. 2010 is right here. 2016 is right here. So, and then they are given the figures, okay? So the other pair they want is, and then X is year. So it's 0 because 2010 is 081, right? And 467, sorry. You see that, right? That's what they want, man. 467 and 081. All right. Then it says, okay, see what it's saying there in C? Use the two other pairs from B to write an equation of a line that models the data. We're doing data modeling. It models the data, okay? Give the final equation in slope-intercept form. Okay, so what they're saying there, we got 2 points. So basically number C, I don't know why I put C over there. Let me move it over here. Forget about that. I got space on the left. So C, number C, we have 2 points. Then we get the oh sorry, we're gonna get the slope first. We'll get the slope m is equals to, we use that initial final. Slope is equals to change in y over change in x. What is that? It's a 467 minus 81 over 6 minus 0. You see that, right? So if you simplify that, what do you get there? I hope you see what I'm doing, right? You get 386 over 6. That's what you get. Alright, so we're gonna have to work with decimals, okay? Okay, so that's equals to 64.33. Okay, since we're working, you know what? Let's remove 1 3. Yeah. Okay, so like that. Alright, it says what is the answers? Okay, we need slope intercept form. We can use the first one. The I will say y minus y1 is equals to mx minus x1. You remember that formula? Then say y minus 81 is equals to, the slope is 64.3. Okay, I'm sorry, what am I doing? Times x minus, what is x1? We have to put in x1 there is 0, okay? Alright. So we'll have y minus 81 is equals to 64.3x, because the rest are 0. So we'll have y equals to 64.3x minus, plus, it becomes plus 81 when you move it over. So that's what we're looking for. See right there? That's the slope intercept form we're looking for, okay? Alright, so since we got plenty of space, let's remove that. We'll move it up. We got plenty of space now. So that's what they're looking for there. So then we'll say D. This is D here. Okay, actually say to the nearest 10. So we'll leave it at slope 64.3. Okay. So what is the answer? Use the equation from C to approximate the number of linked-in members in 2014 to the nearest. Okay. So we got, what did we get? You want us to use this? What we got is a 64.3x plus 81, okay? And it's telling us to use that to approximate the members in 2014. What is 2014? What is the value of x in 2014? Of course, this is 0 is 2010, 2013, 2011, 2012, 2013, 2014. So their x is equals to 4. And then you want to y represent the members. So with that, we say y is equals to 64.3 times 4 plus 81. That's what they want us to do. You see that, right? So that's 257.2 plus 81. Okay? Okay, so we'll simplify that. We'll get 338.2. I think that's a million, right? Let me see. Yeah, it's a million right there. Members is a million. So it's 338.2 million. That's what I got. So what else do they want us to do? How does the answer compare to the actual value? Actual value of a 33. Okay, the actual value is 332 million. Okay, I think it's only a little off, man, because we got that. We'll compare it to. It's close, but not it's off. What we got is higher. Calculated, okay? Calculated is higher, okay? Higher than actual, okay? Because look at the number, it's really high. because we're off by about we're off by 6.2 million. So, but we're done with that problem. So we'll move on to something else. Okay, here is the next problem. It says the graph shows worldwide snowmobile says Y for selected years X, where X equals to 0 represent 2000, X equals to 1 represent 2001, and so on. Use the graph to work each problem. Okay, we've seen something like that before, so it's not a big deal. Roman numeral I, what does he say? Is the slope of the line, hang on a minute, is the slope of the line in the graph positive or negative? Of course, if you look at the graph, you go from left to right, it's sloping. If a car is there, it will be going downwards, you see? So it's slanting down towards the right. So it's negative. It's a negative slope, okay? Negative slope. So, and then it's a B. It's Roman numeral 2. It's it says two other pairs are showing on the graph. See, they gave you that, and they say use the other pair to find the slope of the line. Okay, so you are given 0209 and the 117 year 17 119. Okay, the slope is equals to change in y. That's another way you write delta y, abbreviation delta x. It means something, changing y over changing x. You do that, you get initial final, okay? We'll say 119 minus 209 over 17 minus 0. What do you get there? You do that, you get, you should be able, let me see, you do that, you're going to get negative. You're going to get negative number, 90 over 17, okay? Okay, so if you do that out, you get minus 5 over 3. That's what you get. Okay, so you can check that out using whatever you want to use. Actually, it's 2.9. Okay, but 3 is okay. We'll move it over to 5.3 instead of 5.29. Okay, so that's the slope. Slope is there. We got the slope, right? Okay, so what do they want us to do? Okay, that's actually A here. What is this? What is they want us to do? Write an equation of a line that models the data. Pick up on the equation of the line that models the data given. Give the final equation in slope intercept form. Okay, so we got the slope. Then you use this point slope formula. Mx minus x1. We use that. We get y. Okay, that's B, right? Oh yeah, that's B. We'll put B there. So that's that's B here. Okay, so we got the slope. Then we'll use the first point. We'll use this one. We'll say y minus 209 is equal. So what is the slope? Negative 5.3. Okay, and then x minus, what is the x1? 0, because we're using the first point. So you simplify that, you get y minus 209 is equals to minus 5.3x. The rest is 0, okay? So you say y equals to minus 5.3x, all right, plus 209. That's what we got for the model. That's the model right there. Okay. And that's his slope intercept form. This is the slope, and this is the y-intercept, okay? Use the equation from part B to approximate worldwide snowmobile sale for 2016. For 2016, because you see the year, remember what they say, x equals to 0 represent 20, represent 2000. X equals to 1 represent 2001. So if you keep going like that, 2016 will be x equals to, you get that right? I hope I'm correct. 2016 will be equivalent to x equals to 16, okay? So they say use the equation part B to approximate what numbers Slomo cells for 2016. How does the answer compare to the actual cells of 127.0 thousand? Okay, so then we'll put that in the equation. We'll get negative 5.3, okay, times 16 plus 209. Okay, so you simplify that. You gotta simplify all that, you see. So I guess, okay, so that's what you get there. And then you simplify further, you get 124.2. That's what we got. What does that mean? Use the equation to that's the cell in thousands, right? The cells are in thousands. So that's in thousands, okay? That's what we got for 2016. And then he said, how does it compare to 120, the actual cell 127? So if we compare the actual is let me see, cells in thousands, okay? Actual is the actual figure. I'm gonna give me a minute. The actual figure is actually, what is that? 127.0. 127.0. You compare. If you compare it to 124.2, it's off, man. The whole thing is off. It's off. Okay, it's off. Alright. Yeah, it's kind of off. I would say it's off. Yeah, the equation gives low. The equation is low, okay? This is low compared to the actual, okay? That's all I can say there. But we'll have one more problem. Number 3, what does the ordered pair this mean in the context of this problem? The ordered pair is, it means the year. Okay, sorry. I didn't see we'll have one more problem. Let me divide it like that. That way we can solve that one. So that's Roman numeral 3. Okay. Alright, that means the ordered pair 129.5. What does it mean? That's what they ask in the context of this problem. It means in the year, because what is that? X equals to 16 is 2016. So in the year 2015, right? They saw the cells in thousands. Cells in thousands, okay? In thousand was 129.5. That's all that is saying, man. Okay, so that's all that is saying. So you see, 2015 they sold 129,000. That's 1,000, you know. So that's actually put K. That's 1,000, you know. So 129.5 thousand. Okay, so that's all that is saying. I'm done with that, man. All right, we'll move on to something else. All right, I think I'm gonna end it on this problem because the 2 other problems I had for you, they are mistakes, so they have nothing to do with this. Now I'll leave it there. But anyway, subscribe to my channel, please. Like and share this video. Leave comments or questions under the video. And thanks for coming. I will see you in the next topic, okay? I think I decided I'm gonna do exponents and what do you call that thing? And polynomials, and that's those are two topics are very very interesting. So we're gonna move on to that next. Okay. So let me end the linear equations in one variable and two variable here. Like I said I may come back and solve a bunch of problems. If I do, I solve a bunch of problems, then I post it under this topic, because I have my YouTube channel divided into topics, okay? So that's the plan we'll have. When I go through it, I may come back and start solving a bunch of more problems, more application problems, adding them to where they're supposed to belong, okay? All right, thanks for coming. See you in the next video.